Okay, let's look at problem uh, uh, part C of problem 1. Okay, so we're looking at 1C, and here we've been told that the sensor output is not directly connected to the ADC. We are giving it through a signal conditioning circuit. So that's your signal conditioning circuit. Okay, and what we'll do is we'll connect it to the ADC now. Yeah. So this is what we want to do, and the question in part 1 is asking us to find out what is the kind of signal conditioning that you require. Now we already know what is the output of the sensor that we're going to get, right? We calculated it in the previous problem. The sensor is going to give us 600 millivolts to 800 millivolts. And what we want to do is, if you want to use the complete range of your ADC, you want the limits here to be 0 to 3 volts. Okay, so how do you convert this 600 to 800 millivolts into 0 to 3 volts? And let's assume that we use a linear mapping. And if we use a linear mapping, what we can say is, well, let's call this, let's say V in, and let's call this V out. Okay, so first we can subtract V in by 600 millivolts, right? If you do that, what will you get? You would have converted the 600 millivolts to 800 millivolts range into what? You would have converted this into 0 millivolts to 200 millivolts, right? And now let's amplify this. Sorry. Let's amplify this so that you get 0 to 3 volts. So we want to make 200 into 3. So how would you do that? What is the gain that you would require? If you have a gain of 15, you should be able to do that, right? So 15. So we want V out equal to 15 V in minus 600 volts. No, 600 millivolts. Okay. So that would give us the transformation that we want. Now the second part is to ask the question, okay, how are we going to make this kind of a circuit? Now there are various ways of making this circuit, right? You could make, I think the easiest would be to say, okay, I'm going to do a subtraction first. So I'm going to have V in here. I'm going to give 600 millivolts as the input, and this is a subtractor circuit. You could call it a subtractor, or it could be a differential amplifier, right, with a gain of 1. So that would be a subtractor. And then what you do is you give it to a non-inverting amplifier with a gain of what, with a gain of 15, right? And that's your V out. So, I'm sure you know how to make a differential amplifier. You know make how to make a non-inverting amplifier, and you in the problem sheet you are asked for an entire circuit for the same. And if you have a problem, just look at the solutions, and the solution is there. Okay, lastly, what we've been asked to do is we've been told, okay, what is the temperature resolution of the sensing device with the signal conditioning? Okay, so we are asking, now that we have the signal conditioning at this point, does the temperature resolution change of the measurement that you're doing? Yes, of course it changes. Now what's happening is, now let's so the temperature that you're measuring, that the sensor is measuring, is 30 degrees Celsius to 40 degrees Celsius, isn't it? So this 10 degrees Celsius is being converted into 256 levels at the output of the ADC. So what's the resolution going to be? It's going to be 10 degrees Celsius divided by 256, which is going to be equal to 0.039 degrees Celsius. Okay, so it's as simple as that.